Hi, in the last videos, we discussed about correlation between two variables, okay, and we mentioned that correlation does not imply the causation, meaning that if there is a correlation between two variables, it doesn't imply that one variable is causing the other variable, or the increase or decrease of one variable causes increase or decrease of the other variable, okay. So correlation just say that they are related to each other, okay. And also we discuss about the measure of agreement. Okay, we did both. We did in R and manually. Okay. So next thing we want to do is the regression analysis, where we discuss about the causation, meaning that one variable is causing the change in the other variable, increasing or decreasing certain pattern of change. Okay, let us discuss about that. Correlation between two variables does not necessarily imply cause and effect. For example, birth weight and systolic blood pressure appear to be associated. High birth weight tend to have high systolic blood pressure, but it does not necessarily mean that increase in the birth weight cause increase in the systolic blood pressure. If increases or decreases in a variable cause increase or decrease of the another variable, then the correlation is called the regression. Okay, so if one causes the other, then we call that association, that correlation, as a regression. Okay, if a variable depends on another, not vice versa, then the former variable is called dependent and the later variable is called independent variable. So what that means is, if there are two variables given or more than two variables given, okay, if one depends on the other variable, for example, you can see that the weight of the person depends on the height, right? If there is a bigger height, then it will be, the weight will be bigger and bigger, right? So the weight depends on height, but height does not depend on weight, right? So whatever weight you have, the height does not depend on that, right? So weight depend on height. Weight of a person depend on the height of the person, but height of the person does not depend on the other. That's what he said. Look at that. If a variable depends on the other variable, but not the vice versa, then the former variable is called dependent. So the weight is dependent, okay, and height is independent. So weight depends on height, but height does not depend on weight. That's why. For example, the blood pressure may depend on other factors too, but age is one of the independent variable. Okay, so blood pressure depends on age. Whenever the age increases, blood pressure also increases, right? The term simple regression is used if there is only one independent variable. If there are many independent variables, we call multiple linear regression. Okay, the simple regression or multiple regression. The simple regression is used if there is only one independent variable. Example, blood pressure and age, or blood pressure and salt intake. If you increase the salt intake, then your blood pressure go up. That's why blood pressure is the dependent variable, because the blood pressure depends on salt intake. Blood pressure also depends on age. So if you say blood pressure depend on age and salt intake together, then that will be the multiple regression. Okay, all right. The line of best fit, also called regression line, is a line that goes through most of the data points. Look at that. Suppose these are the x variable, these are the y variables, these are the x-axis is the x variable, y-axis denotes the y-axis denotes the y variable. Okay, suppose these tiny circles are the data. Okay, that line, that blue line, that goes through most of those or close to most of those data points is called a regression line. It is also called least square or line of best fit or trend line and so on. Okay, so in other words, the regression line is the one with some of the square of the error is a minimum. Okay, for example, what does that mean? That means, look at this. So this is a line that goes through the middle of those points, right? So that point, okay, this point is basically the given point, that is the data point, right? But that line is the regression line. That means that line represent most of those data points. That line goes from the middle, means that line represent most of those points or predicts most of those points. or estimates most of those points. Okay, so you see that this is the original given line, right? A given point, but this point is the estimate for that point. You see that? So you see that the estimate is smaller than the given data point, right? So the difference between that estimated point, the estimated value, and then the given value, that difference, that is the dotted line, is called the error. Okay, we write D1, that is the deviation between the given data and the estimated line. Okay, similarly D2, you see that the given point is below that estimated line. So here D2 is a negative value, right? Because that error is negative error. Similarly, D5, D6 are positive, and D3, D4, and D7 are the negative. So errors are negative. Okay. So you see that the regression line is the one that has the smallest error. Sum of the square error is smallest. Okay, minimum error. Meaning that if you draw this line below those or above those, then the error will be bigger because those lines will be further away from most of those points. Okay, so the best fit line or the regression line goes through most of those points. That's why the error, sum of the square of the error is minimum on that line. Okay, regression lines are very useful to see the trend and make predictions on the basis of the data. Okay, so how do I find out that line? Okay, so basically there are many types of regression. Okay, so we will discuss in this course, we'll discuss the linear regression. Linear regression means all those data points will be estimated or predicted by a line segment, right? There may be non-linear regression too. We are not focusing on that. We are focusing only the linear regression in this course. Okay, excuse me. So how do I find out that line that goes through most of those points then? Or how do I find out the regression line? So there is a formula to find out the regression line. This is the equation for the sample regression. You have seen these kind of things in your statistics class too. Okay, the elementary statistics class. So formula for the sample regression line, sample linear regression, is a line we denote by y hat. Y hat is a plus b times x. Okay, so where x is the x values, x data, y hat is the y data. Okay, we use that x and y values to determine a and b. Okay, we use x and y values to determine a and b. So the equation of the line is y hat is equals to a plus bx. Again, so this is the equation of that line. Okay, to find out the equation of that line, we use y hat equals to a plus bx, where a and b are found by using the x data and y data. What is b? B is n times summation xi times yi minus summation xi times summation yi divided by n summation xi square minus summation xi whole squared. Okay, so what are the columns do you need for that? So to find out the value of b, you will need the columns for, let us depend on the formula, let us based on that formula. Okay, what does it say is, you say that you will, so x and y will be given to you, x and y will be given to you. Okay, what else do you need? You need x times y, and then what else? You need x squared. Okay, that's what you need. Okay, now first of all you need to find out what is n though. N is the number of pairs. Okay, so if you want to do by hand, then you will have like the values here, right? Some values here, and then also other values will be here. So you need to multiply x and y to find out x times y. Okay, and then you do x squared, square of x. So you need to do x square of x, right? Like this. Okay, now you see that. So what is n? N is the number of pairs. 1, 2, 3, 4, like this, right? You need to find out summation x. Why? Because there is summation xi square. So these are the summation xi, summation x or summation xi, and then you find out that, and you need to square this one. Okay, so what else? Summation xi square. So you need to find out summation x square, and then whatever you find out, you will use that. Also summation x times y. That means you add all those and write down here add all those and write down here, add all those and write down here. That is for B, okay? And similarly, you need to find out summation yi also, summation y. Also find out summation y. You need to find out that. But to find out A though, A is summation yi times summation xi squared minus summation xi times summation xy. Xi, yi, okay? And then times, so divide by n times summation xi. So the denominator is same for both, right? So what you need here is, you don't need anything new. So you have, if you have just 4 columns, you are good. Okay, now you need to find out, so you need to plug in these values. Summation xi, yi, that is summation xy, you plug in that, times n is the number of pairs, minus summation xi times summation yi, divide by summation xi squared. That's what the summation xi squared times n, minus summation xi whole square of that. Okay, you plug in that. And to find out A, so B is the slope, you see that? Y equals to mx plus b. B is kind of the slope here. All right. So is the slope or regression coefficient from the sample, and A is equals to that is the y-intercept, because you see that A is the y-intercept or the regression line. So x of I equals to values of independent variable. Xi must be independent variable and yi must be the dependent variable. The population parameter for A and B are alpha and beta respectively. So this is for the sample regression line. For the population regression line, we don't write y hat. We just write y equals to alpha plus beta times x. That's what you write. Okay. X is the population independent variable for the population. Y is the independent variable, dependent variable for the population. And for the sample, we write y hat equals to A plus B times x. This is for the sample. Okay, this is for population regression line. Okay, guys. All right. So this is what you you use manually if you want to find out the correlation coefficient. There was manual way and then R method, right? And if you want to find out the equation of the regression line, this is a manual way. We'll find out, we'll use R as well. Okay, it is similar. Okay. If the slope of the regression equation is positive, that means if the value of B is positive, that is B is positive, we can interpret that for every 1 unit increase in X, we will get B unit increase in Y. That means, because this is the slope, right? What is the meaning of slope? Slope is the rate of change of Y when you make a unit change in X, right? That's what the slope is. So similarly here, what does the B stands for? If B is positive, there will be increase. If B is negative, there will be decrease, right? So what that means? That means if you make 1 unit change in X, then you will see B unit change in Y. If B is positive, then you say that if you increase 1 unit in X, then you will see 1 unit or B unit increase in Y. That's what it means, okay? And if B is negative, then there will be decrease. The number B is called marginal change. Let us see one example. So here, the following data is the pulse rate per minute and systolic blood pressure. Okay, find the equation of the regression line. Y prime equals to A plus BX, where pulse rate is considered as X and systolic blood pressure is considered as Y. What does that mean? That means if a person has pulse rate 86, he has systolic blood pressure 126. Another person has pulse rate 72 and his systolic blood pressure is 104 and so on. Okay, this is the data given. So you want to find out the line of best fit or line of regression, and also you want to estimate what would be the systolic blood pressure when the pulse rate is 84. It is 84 is not here, right? The pulse rate 84 is not here. So I want to find out what would be the pulse rate if the systolic blood pressure is 84. Okay, all right. So to find out, if you want to find this manually, then what should you do is you need the columns for X and Y. This will be X, this will be Y. You copy that and then find out X squared and find out XY. And then you use that formula to find out A and B, and then you plug it into that equation, right? That's what you do. But if you want to, I want to show you how to do R directly, okay? So if you want to do R, then you copy that first data as pulse. I just copied that. And second data is the systolic blood pressure. The par MFRO1 is just you want to see the plot in only one plot there. So what that means is, let me show you. So if you want to show multiple plots in the same graph, then you will do like 2 times 1, 2 times 3, like that. But we want to see just one plot. That's why I'm just doing per. I mean, you don't need actually this one if you don't want to. Okay, you can just run the plot. So on the plot, I'm doing along the x-axis, I'm doing pulse rate, and along the y-axis, I'm doing systolic blood pressure. Okay, and main is the pulse rate versus systolic blood pressure. That will be the title. Okay, let me run that. This is what you see. You see that it doesn't look like a very much relation or very much like a regression there. Okay, because increase in one doesn't look like increasing the other one because of these two data sets. But we want to find out how it looks like. Okay, so to find out the linear regression line, the R code, the built-in code is LM. That is the linear model. LM, and always first one you need to do Y and then that wiggle sign and then X. Okay, so this is just a name. You can give any name on the left side. So LM is the main function that calculates the regression line. That gives you value of A and B. Okay guys, A is the y-intercept and B is the slope. Okay, so you do LM, and then first of all you need to do the dependent variable y. First of all you need a dependent variable y and then that sign, and then you do independent variable x. That's what you should do. Okay, let me run this line. What you get is it doesn't show you anything because we gave some name there, and you need to write that name and run that code to see the result outcome. Okay, look at that. What that means? That means the value of A is 117 and value of B is 0.04584. Look at that. So A is, oh I'm sorry, this is not the value of A. So A should be 117 and B should be 0.04584. Let me make this correction. Okay guys, let me do that. Alright, so A is 117.455. That's what you get from R. And B is 0.04584. You see that? So the pulse, this is the coefficient of pulse. Coefficient of pulse means coefficient of x is the pulse. Okay, that's what you get the slope. That is the B in our case. And then the y-intercept is 117.455. That is the y-intercept. Okay, now, so what is the line of regression then? The line of regression is, so what is the interpretation? Let us write the interpretation. There will be about 0.045 increase in the systolic blood pressure for every increase in the pulse rate. That's what we see. Okay, because that is the meaning of the slope. All right, so what is the equation then? The equation is y hat equals to A plus bx, and that gives you 117.455. That is A plus B is that value times x. Now if you want to find out what is the value of y when x is 84, you replace x by 84. You get x equals to 84 implies y prime is 121.30. That's what you get. You see that? That is the model 1. That is the value of A and B. And I wrote x equals to 84, and I wrote the equation for B 117.455 plus 0.04584 times x. And then if you write that value, you got 121.3056. That is the line of regression. Okay, so if you want to know how does that line look like here, okay, what you need to do is you need to do AB line and then model 1. That's what the model 1 is, right? AB line, that name of the linear regression or linear model, and comma, I did the color equals to red. So if you run this code, what do you get? This is what you get. You see that this looks like almost no increase, but it is a very tiny increase there, right? So we are not doing the hypothesis testing. Later we'll be doing the hypothesis testing for if the slope is significantly different from 0 or not. We'll be doing that, and then we will test for the significance. But for now, that's the line which is almost horizontal. Okay, now what I want to do is I want to find out the prediction for all the values. Okay, so what we want to do is we want to find out the prediction interval for it, because what we got here is for x equals to 84, you got the predicted value or the y value is 121.3056. But what is the 95% confidence interval for this case? So we want to know that too. For each of these x values, if you want to find out the prediction interval, because these are the real data, right? These are the real data. Now you want to find out the predicted data. So how far are the predicted data? Do you see that the predicted data, some of these values, the predicted value will be far from the real data, because this red line is the prediction line, or the predicted line, or the estimated line, or we can call a regression line, or line of regression, or best fit line. That's what we call. Okay. So if you want to do that, so what I'm going to do here is I'm writing the pulse and the systolic blood pressure into two columns. This is what you write. This is the data we have, right? And if you want to find out the prediction interval, you do predict and model 1, and then A is that data values, right? And then interval is prediction. Okay? So if you want to do that, then this is what you get. So what does that mean? This is the fit value, meaning that what was the first value of x was 86, right? For x equals to 86, the real data is 126, the systolic blood pressure, but the predicted value is 121.3973. That's what it says. You see that? And then this has the lower bound, 95 on the confidence interval. The lower bound will be, this is 95% confidence interval, okay? Lower bound will be 71.95. And then upper bound will be 170.83. That's what it does. Okay. Similarly, when x is 72, when the pulse rate is 72, in that case the real data you found was 104, but this predicted value says that it will be 120 in that case. Okay. That's what it is giving. This is giving as 120. The predicted value is 120 with prediction interval as 71.96 through 169.54 and so on. Okay, so basically you can find out the fitted value. This is the red line. Okay, for each of these x value you can find out the fitted value, red line value, and also the interval for that fitted value. Okay, lower bound and upper bound for that interval. This is the prediction interval for that. You can do that too, but the main thing here is finding the line of regression y equals to a plus bx using R. So it is not bad. Just write down the x data and then y data, and you don't actually need the plot as well. So what you can do is you can give a name. I gave a model 1, and you do linear model LM, and then parenthesis you need to write x first, and then that wiggle sign, and then you need to write y first and then wiggle sign and then x. That's what you do, and then write the model 1. That will give you the value of a and b. Okay, so the slope is the b value in this case, because we are writing a plus bx. So slope or pulse, the coefficient of pulse, because you see that whenever you run this, the pulse has the coefficient. That means pulse is the x value here, so the coefficient of x, that is the number multiplied with x, that is b, right? A plus b times x. This is the value of b. This is the value of a in this case. Okay, guys? All right.